Concept we are going to discuss is interfaces. So basically interface is you can say different things. Interface is a contract. Interface could be a shared behavior. Interface can be an agreement. Interface can contain a collection of method signatures. Uh, you know, the interface defines a contract type, what methods a type must have, but it doesn't specify how those methods should be implemented. Okay, you can say interface can be a contract. Interface is a shared behavior. Interface is a contract. Interface is a shared behavior. You know, what interface contains? Interface contains collection of method signatures of a type that implement, but it does not contain how methods to be implemented. What methods to be implemented is it contains, but it does not contain how the methods to be implemented. Fine. A simple example: you have a laptop. You have got USB port to your laptop. So it's a specification. You can call it as a specification as well. There are different definitions. Interface is a contract, an agreement, or a specification. Shared behavior. Interface contains collection of methods. You can tell many things. You specify the behavior, but you do not implement the behavior inside the interface. Of course, the type has to implement the behavior. Let's say that you have a laptop that got USB port. So there are so many companies who they are developing USB devices. It could be a mouse, or it could be even a light. It could be a pen drive, USB drive. It could be a keyboard. It could be even a wireless router. Like that, you can insert many things to your USB port. Okay, even you can directly charge your mobile if the USB cable is supported, etc. But if you look at it, the manufacturers of the USB devices and the manufacturers of the laptops are generally different. Could be same as well, but generally different. But you know, uh, how do they know that whether their USB device can be inserted and work seamlessly with the USB port on a laptop? Let's say the laptop is Dell. uh, you know I get a Kingston USB pen drive, USB drive. So how does Kingston know that the pen drive can be inserted into the Dell laptop, vice versa? Because both of them, or all the organizations, they follow a specification, they follow a contract. Okay, I'm making, okay, this is the USB port. So all USB devices, okay, with this particular USB port specification, maybe USB or USB-C, whatever it is, should be inserted with this particular USB port, should work with this particular USB port. It's a contract. Similarly, you have electric sockets, and then you have uh, electric devices. You have gold medal, you have ABB, you have Honeywell, okay, you have GM, okay, like that. There are so many anchor electric socket companies, and then you have a lot of electric devices. uh, it could be a fridge, it could be a television, it could be many things. Okay, so there are many electric devices. So you don't go and purchase a separate device. a separate socket for every device you purchase, because almost all the sockets can work along with it. That's an interface, it's a specification. Fine. So there are two things here. First, we see that how the existing interfaces are implemented. At least we take an example of one or two. And the second thing is we will create our own interface and then implement that interface. Okay, two things. Right. And third thing is we will develop some design patterns, maybe Fluent API, builder pattern, dependency injection, basic, a simple dependency injection kind of a design patterns we can use. How we can use with the interfaces. Okay, let's get started. Let's say that I have a we already have a function fmt dot print line. You know that the print line function is going to print the print line is going to print anything onto the console. But if you look at it, there is a function called fprintline. fmt.fprintline. So generally println function prints on the console or terminal, whatever that this particular application is attached to. But if you look at fprintline, the first parameter is a io.Writer. So where does this write to? Fprintline, where does it write to? It writes to a type that implements io.Writer. io.Writer is an interface. Generally in Golang, interfaces ends with er or or, but it's not always possible. Okay, so you can think of it at least er or or are mostly for interfaces. Again, it is not a strict rule, so you can use a some naming convention. Some folks write with I, start with I and all. Fine. The first parameter is os.stdout. Okay, os.stdout is implementing os.file. You see that where os.stdout, which is of type os.file. stdin, stdout, and stderr are open files. These are called as open files, pointing to the standard input, standard output, and standard error file descriptors. Because in most of the Unix systems, they work in this way. In Unix systems, everything is a file. So what I said, I want to print line to std out. Okay, let's say I say hello world. os.std out. I say hello world. It has printed on the console because the implementer of IO reader, IO writer, the implementer of the IO writer is the standard output, std out. The implementer of the IO writer is a standard std out, os.std out. This is how it implement it. This is how that means os.std out has already implemented io.Writer, which is what actually std out. It's a file basically. It's a file. You can see os.file. You go here, os.file. If you look at os.file, this is os.file. The os.file might also already having the writer interface. I'll show you. Don't be confused right now. So here we passed a type. That type has implemented io.Writer. io.Writer. What does io.Writer contains? io.Writer is an interface. Writer is an interface, which is from the package called io. Writer is an interface, which contains a definition. The definition is called write. Write is the definition. What does the write do? Write has one input parameter, which is a byte slice, and it returns two return types. One is called the number of bytes it is written, and the other one is called error. If there is any error, it returns an error. So any type, any type that qualifies any type that qualifies this, any type that qualifies this particular io.Writer could be part of this. That means if I am writing, so let's say hello world, I would like to write to std out. I can say os.std out. I want to write it to a file. I can implement to the file. I want to write it to an SMS. I can implement as an SMS. I want to write an email. I can implement it to it as an email. Okay, it doesn't matter how it implements. What it does, it always matter is, you know, uh, what type gonna implement that. So let me just do a simple implementation over here. Let me create my own file, file write, file writer, file name. I give file name. So what I do is I create a new object, new file writer, file name, which is going to give a new object called file writer, return address of file writer, file name equal to file name. After this, so how can this type satisfies this particular io.Writer interface? Again, if we go to io.Writer interface, it contains a method. This is the implement. This is how the io.Writer is. This is what the io.Writer is. So I need to implement a function method like this. If fw equal to nil, return 0 comma errors dot new nil file writer. Otherwise, what I do here, otherwise, I open a file os.file open file, sorry, open file. The name of the file is fw.file name, and the flag, actually this flag tells that Flag, generally wherever you find flag, it is a bitwise logical OR operation. That means these flags are here, it is an integer. That means there is a 64 bits are there. Zeros are ones. Based on zeros or ones, actually the flag operations happens. Okay, for example, a simple thing. Let's say I create a flag. Let me create a, for example, I create a, let's say I create something called status. Status is byte, where status is byte. Status has got 8 bits because it's a byte. It has got 8 bits. That means by default 0, 0, 0, 0, 0, 0, 0, 0. These are the 8 bits. Generally, whenever you see flag, what happens is simple status, okay, can have multiple meanings. Just by using one byte, you can make it as 8 different meanings. How can you make it as 8 different meanings? For example, the first byte, actually here, this is the first byte. The first byte is 1, it could have a different meaning. The second byte is also 1, it could have different meaning. These are the flags. That means there could be something like this. These are the bitwise logical operators. That means logical OR operator means if it is a 0, it becomes 1. If it is a 1, it becomes 0. That's what bitwise operators. So just with one byte, okay, you can have 8 different variations. You can represent this particular one byte with 8 different variations. That's very bitwise operations are very uh, good actually. You don't need to really create a string and then consume a lot of bytes. So similarly, if you look at this particular implementation, the second parameter is flag. What that this flag contains? This flag contains different values. What the file is for? The file is for os.o create. If the file is not there, just create it, or os.o append. If the file is already there, append to it. os.o maybe read, write only, like this. And the third one is called file mode. You know, 0644 is the mode. If you are aware of the Linux based file modes, this number is very important. If you are well aware of this 0644, how file modes, what is it? File modes. If you look at file modes in Linux, actually 4 bits are used for file mode operations, file operations. It's a number basically. Number is used. The first one, let's say 0644 is the number I gave. The first one talks about whether it is a file or directory. Okay, you can see that lsll. See this one. This is exactly what we are doing. The first one talks about the whether it is a directory or a file. If directory it is 0, a directory it is 1, file it is 0, so it is a file, so we talk about 0. And this number is very, very important because there are three numbers. How does this number come set as this? The first one talks about the user, group, and anybody. User, group, and anybody. That means what user can do, what a group can do, and what any other user can do. There is a read operation which is called for. There is a write operation which is called to, and there is a execute operation which is called one. So the user can read and write. Since it is not an executable, it's just a file that we are gonna write. So 4 plus 2 is 6. The group, other than the current user, the group should only read the file but should not write or execute the file, which we call it as 4. Others, anybody else in the system other than the user, can only read the file. So generally some folks they do blindly 777. It's a very big vulnerability. You're giving 777 means you are giving access to all access to everybody in the system. The user can read, write, and execute. The group can read, write, and execute, and the other users also can read, write, and execute, which is not a safe operation. So you should know this what you are giving over here. 0644 means here it's a file the user can read and write because it's not an executable, so there is nothing called execute. A group can only read the file and other users also can only read the file, cannot write to the file. Fine. And then file.write p return, because this is also returning n and error, so I just return. There is something called defer file.close. Okay, this defer we will discuss about it later. Keep it in your mind. Line number, I mean, example number 49. Okay, this differ has lot and lot of meaning. It looks pretty simple thing, but differ is much more bigger than that. We will discuss. What exactly we are telling? Just close the file. Differ close the file means close the file towards the end of this particular function. Even though you wrote here, it is closer to the end of the function. So right. What this write is, this write is, and one more thing in Go language, in other programming languages, whenever you are implementing an interface, implementing an interface, you need to explicitly tell that an interface is going to be implemented. Okay, you need to explicitly tell, hey, I'm implementing an interface. Okay, uh, like extend keyword or colon keyword, implements in Java or colon in C sharp, etc. But in Golang, you don't need to tell that you are implementing an interface. As long as the method signatures are satisfied, automatically the Go type system can understand that, okay, this is implementing this interface. If the method signatures are satisfied, that's it. You don't need to specially use any keyword or anything that to implement an interface. Method signatures are more than enough. Right. So what I do here is file writer, new file writer, maybe data.txt, and you see that I just created one object. The way how an object is variable is created over here. Similarly, I created an object. Then fmt dot f print line. Now I want to print it to fw, comma, hello world. Sorry. So what happened? When I run the example, it writes to a file. You see that data.txt. It is written to the file because the object that we are passing here is a file writer. What file writer has implemented this particular interface, writer interface is you write to what actually you write to a file. What file it is? Whatever the file that you specify here, file name. Here also you do the same. Here also you are doing the same. But here the actually descriptors are internal descriptors because std in, std out and std error are three descriptors which are already created. But here I don't know which file to write, so I want to specify the file name. That's what you have done. And then you pass this object over here. So whatever you write it here, it is written fmt dot f print line file writer, comma. It is written to the file. So this is a kind of a dependency injection. There is a dependent object and there is also an independent object. The dependent object is FW, the independent object is the interface. We will discuss about it little later, next session. So this is how you can implement an interface, existing interfaces. You are calling an existing interface, you are implementing an interface. Now what I want you to do is a simple thing. Instead of file writer, you write it as an email writer or telegram writer or slice writer. Whatever you pass it here, it should be sent to an email or a telegram. Telegram is relatively easy, comparatively easy, because pretty easy to set up a telegram bot. Check it, or an SMS if you have any SMS service available. But it's a paid service, right? SMS. But you can write it to a telegram, possibly to WhatsApp as well. Whatever you type here, it should be written to an object that you pass over. The implementation, where should it write? Should it write to a file? Should it write to a console? Should it write to a telegram? Should it write to a file, PDF document? Should it write to a printer, in fact? Or should it write to a Slack? It depends on what the dependent object that you pass here, which has implemented this particular method signature, which is called write. Okay. And this is how the basic about interfaces. Okay. Just to uh, once again summarize, interface is kind of a contract or a specification. It contains a collection of method signatures, but those methods are not implemented. The concrete type, the concrete type implement those methods which are mentioned in the interface if the type has to be adhered to the particular interface. If the type wants to be part of the interface, if the type wants to be part of the contract, it has to implement those methods of that interface. But interface itself doesn't contain any behavior. It just contains the signatures, design, specification. In Go, you don't need to explicitly say that, hey, this I'm the type called file writer, I am implementing an interface called io.Writer. You don't need to say. As long as the signatures are satisfied with that particular interface, that means it is automatically already satisfying the interface. Explicitly, you don't need to say. Explicitly, you don't need to go and say that I'm the type called file writer. I'm implementing an interface called writer. No, you don't need to say, which is automatically Go can understand that. Okay. We have not created any interface. In this first example, we are using the existing interface. How does a new object, new type can implement that particular interface is what actually we discussed. In the next session, we create interface and we implement interface, and we also see some different design patterns. We also look at the type assertion with respect to interfaces, because type assertion is a concept not on only on any, it is basically on interfaces, and how interfaces are created and called inside the runtime also we will discuss, so that you have some clarity on how the interfaces are created runtime. So for some folks say that polymorphism can be implemented using interfaces, multiple inheritance can be implemented using interfaces. I don't believe that, because polymorphism and multiple inheritance are the concepts of object-oriented programming languages. Go does not support those concepts. Just for the understanding sake of understanding how things done, similar to Java or similar to object-oriented programming, we can have a look at it. Even I don't believe that interfaces can. I don't uh, agree that interfaces can do multiple inheritance within interfaces. Inheritance is inheriting the behavior. Interface is not a behavior. Interface is just a specification. So, if you ask a question, how can I implement multiple inheritance in Java? The answer people give, even the search engine gives us interfaces. But interfaces are entirely a different concept than inheritance. Interfaces are entirely a different concept than inheritance. So, you can't do the answer is you can't do multiple inheritance in Java. Java can use multi-level inheritance. Rather than answering that, people say that you can achieve it through interfaces. Whatever you achieve through interfaces is not multiple inheritance. It's a different concept. However, we will discuss about all these things in the next sessions.